Welcome back to the part 2 of the chapter 7. And in this part, what we're going to do is to continue where we left off. So let's go back to our PCG building structure PCG graph. Let's open this up. And what we're going to do is add another vector. In this case, will be wall offset. And this will offset the position of the walls. So let me go and add it. Change it to vector. Name to wall offset. So let's go and create the next transfer points. And let's add our wall offset. Add this to our minimum and maximum offset. So let's leave this for now because we're gonna reuse this for later. That's why I created this very quickly. And then what we're gonna do now is actually going to create another set of parameters. In this case, we're gonna look for two vectors. So let's rename this to height. Another one will be copy transfer. And that's very clever because that's what we're gonna actually do is to create the upwards direction for the height. And at the same time, we're gonna copy this transform. So every time it gets new levels of walls that it's going to be created upwards, we need to also copy that and transform that into upward direction. So what we're gonna do is to go back to our BP underscore building structure blueprint. And I'm gonna create a new set vector. So let's go drag it out from graph instance, set vector. Add set vector parameter. Let me add this again. Make sure always connect this to your graph instance so you don't forget this. And I'm gonna call the height. And I'm gonna go copy transfer. Let's split the struct pin here, expose the float values. And I'm going to do is then also create a little numerical operator. By adding those two. So I'm going to first add this offset and I'm going to then use number of floors and connect it together with our, in this case, dimension offset. And the point of doing this is every time we offset the dimensions, depending on the number of floors, it will basically sort of expand vertically, but at the same time also keeping remaining the dimensions of the offsets that are being generated between each wall. So in other words, the number of walls once they're generated and they're going upwards, depending on the number of floors, the dimension offset in between them remains sort of the same without complicating the spacing in between the walls. So I'm going to then connect this to this case Z value, which is going to go upwards. And for the, of course, for this particular situation, which is the copy transform, we need to make sure that our location, in this case, as we are copying the entire transform direction upwards, it has to be done for the location of the actor that we're using for this blueprint. So in this case, what I'm going to do is search for get actor location. And I'm going to multiply this. I'm gonna convert this to float integer, the other pin, and I want to make sure it's set to -1 because it's gonna move different, in this case, opposite direction. I'm gonna connect this just like they are, and I'm gonna kind of refurbish. I'm gonna clean it up a little bit so that it looks quite neat and nice. I'm gonna compile all together, and then let's add another vector parameter. I'm going to drag it out once more and then set vector parameter to wall offset. Connect this. I'm going to split into pins and I'm going to create two new variables here. So one is going to be height up. Turn it to float. And another one will be wall offset. I want to make them public, and also let's just start changing values. So let's compile it first. Change this to 200, just like we had it for dimensions offset here. And also I'm going to set our wall offset to 100. And this time I'm going to use my offsetter I've created. And I'm going to use the wall offset. plug this to X value here. Compile that. And let's go back to our PCG node structure here. So, and I'm going to start adding some nodes that will help us to not only duplicate the walls, but at the same time, those walls will be used to create the heights for the building itself. So I'm gonna literally add them, get actor data. Let's add 2 transform points. And duplicate it once more. And I'm going to merge them once more as well later on. So I'm going to, but first thing says I will need to set this to a mode to work with a single point. And this will help to produce each single point depending on per actor as they move, as the actor transforms and moves upwards in this situation. And let me connect them just like it should be. And this one will be used for the height. This transfer points here. So I'm gonna get the height. And I'm gonna use this offset medium maximum. Now we're gonna create a spline. So I'm just gonna right click, create a spline. Let's go use spline sampler. Let me connect this together. First thing, I'm gonna set this to work with the distance. That's 200 for now. And with this one done, I'm gonna literally connect this to the merge points. So it's gonna create along this spline. So every time we create all this height structure, it will also be duplicated and then move upwards, and then we'll basically turn into create into a spline, which we then added into the spline later on. Go also add another parameter. In this case, we're gonna use get actor property based on the parameter which already is created inside the blueprint, actor blueprint. And I'm going to set this to a height gap. All right, cool. So I'm going to then, the distance we've just created for that is going to be then coded to as a height gap, the distance increment. And now let's go and start copying those values. So in this case, what we'll do, I'm going to use copy points. And I'm going to create a new transfer node. I use those copy transform parameter we've created. Let me just move it a little bit this way so we can see what we're dealing with here. And then I'm going to set copy points settings here. Make sure to set it to target. Rest goes as it is. So because we're going to have to get the rotation target based on the information that we've provided here. So in this case, I'm going to then connect them how it should be. So I'm going to use copy transform to work for offset minimum as well as maximum. Now I'm just going to connect this to input here. And also what we need is to add the switch. So every time we work with this, it switches to different tasks to work with the walls that are going upwards. And in this case, I'm going to use, in this case, called switch. Quite simple, is this what pretty much works like branch. So it switches between which operation is going to take place first and which one's going to be disabled. And this is something very useful because it happens to be working fine if we're going to deal with something like this kind of structure here. Because at the moment we are dealing with lots of going on. And what if we want to use only some particular operation of the task? And of course you can do this by using the switch here. That's what we're going to explain a bit in a sec. And I'm going to just continue as we go. And in this case, I'm going to disable this one, which I'm going to remove the static mesh spawner for now. And I'm just going to connect this to our switch here. Let me just move this out of the way. And I'm going to then use this to work with the target, which means it's already enabled there, right? For the spatial points. I'm going to stick this and connect this to our copy points. And the next bit I'm going to have to work with is that because we're already doing something with our actor data, and as this goes, so what we have built up the walls that are being generated, they are going to basically be copied and moved upwards. And these points that are being generated for the height, and that creates the gap in between the floors that is being generated. It's going to be copied over and then pushed it upwards, and that's what basically copy points doing that for. So in this case, we have created the walls for all the 4 directions. And then because we create another iteration of the walls, they're going to be pushed upwards depending on the height parameter and also the height gap that it's created in between. And I'm going to connect it as a source in this case. Now what I'm going to do is to create a difference node, because we also want to create like a space for, let's say, gaps that is going to create in between the walls, which basically will resemble walls or doors. And for this, we need to use this what I've created already before. And this will be our set point color. So if you drag and drop into this, and of course you already have this in the project, which comes inside the GitHub repository. And so you don't have to worry about it. PCG blueprint already exists. And let's continue as we go and right click and look for difference. And we're going to use this to multiply as well as dictate, remove any overlapping meshes that have been generated from this existing formula, and work with set to points, which will create gaps and openings between the walls. And I'm going to also add density filter. Let me connect this together. It's going to convert it to points here, as you may notice. And I'm going to then connect it all together, just like that. First things first, let me work on the parameters that comes with that. So I'm going to set this to 1 for now. So what's going to happen, the more points you add to this, the more openings will basically be distributed and created between each wall. And the same goes for density. So let's set it to 0.2. And then let's just go and add this, our static mesh spawner. And now what we need to also do, we're also going to add this wall offset that we have created. And then we're going to plug this in between. Just like that. It will regulate the wall's offset position. So now we can start connecting our difference node. So let me just move this a little bit upward. And this will be very interesting because this one goes to default, which comes as a difference. And this will be our source. Okay, cool. So now if we come back and we start working on this, so let's see what's going to happen as a result. Sometimes there's a bit of a glitch. Okay, as you can see, we start getting some cool results. Make sure your walls also, because the moment the height might not work, so in this case, you always keep in mind that the spline sampler always on every spline sampler you work with, always set this to unbound. And that's why things didn't work at the beginning. So just compile this. Now you should be getting some really cool results. And you're still getting the corners issue, but this is very fixable. So you can just basically set this to 0 in this case, and the problem will be fixed. The reason why I want to use this, because sometimes maybe you have some model that you want to change relatively to this offsets that it creates. So you're always trying to figure out a little fix here, so you can use this as a wall offset. This case, so that's why we created a wall offset in the first place. So yeah, you can basically make it bigger if you wanted to, and just expand it. And if you want to increase the number of, let's say, windows that have been generated on each wall, and openings in this case, we can basically go back to our PCG graph, and you can literally set up here. So you can go 50, and every time you move, it should create more openings there. But of course, if you wanted to, you can always create another, in this case, parameter, and declare it to work together within the space here as a PCG inside the actual blueprint, and expose it to variable, and then you can literally control your number of openings inside a detail spanner. All right, awesome. That was pretty much it for this exercise of chapter 7. It was not the easiest to go through, but that's fine because we managed to accomplish this all together. So make sure you review this once more, that video, and go step by step by also following the book directions. If you struggle with a few things, just make sure you revise this once more. And thank you so much for keeping up with this chapter 7 together. In the next chapter, which will be chapter 8, we're going to cover PCG biomes. And that's a kind of new implementation to Unreal, which came with 5.4 version of Unreal. Thank you so much and see you in the next chapter.